we are going to rewrite radicals to identify transformations. Sometimes you're given a radical function where you can't readily see the transformations, but we can do a little manipulation and we can go ahead and determine those transformations. So let's take a look at A. We have g of x equals the square root of 9x. Well, let's simplify that. Remember, we can go ahead and break this down as the square root of 9 times the square root of x. The square root of 9 is 3, and I can't break down the square root of x any further. So I have g of x equals 3 times the square root of x. And again, remember, these are equivalent functions. They would produce the exact same graph, but now here I can easily see my transformations. I can see that I have an a value of 3. So this is a vertical stretch of the parent function by a factor of 3. Let's take a look at another. H of x equals the square root of 4x plus 16 plus 7. So here, notice I can factor out a 4. 4x is divisible by 4 and 16 is divisible by 4. So this is 4 times x plus 4. And then I have this plus 7 on the outside. And again, I can break this down as the square root of 4 times the square root of x plus 4 plus 7. The square root of 4 is 2. I can't break down this x plus 4 any further, so 2 times the square root of x plus 4, and then plus 7. And now I can easily see my transformations. Here's my a value. This is a vertical stretch by 2. My h value is a negative 4, so that's left 4. And then I have a k value of 7. It's positive, so that is up 7. Let's take a look at another. This is from the companion book. However, I did change it a little bit. They had 3.5 in there. I'm just going to change that to a 35. So when I look inside this radical, I can see I can factor out a GCF of 7. 7 times x minus 5. Then I have that minus 10 on the end. And now I'm going to break this up. I have the square root of 7 times the square root of x minus 5 minus 10. Now, keep in mind, square root of 7, well, that's just a number. It happens to be a decimal. So it's okay to have a radical on the outside. My vertical stretch, my a value, is the square root of 7. So a is the square root of 7, which means we have a vertical stretch by the square root of 7. My h value is a positive 5, so that means my parent graph is moving right 5. And my k value is a negative 10, which means I'm going down 10. Let's take a look at 2 that you can try on your own. again, if you're watching this video, if you missed class, I'd recommend that you jot these down, pause the video, jot them down, give them a try, then come back and check your work. So here we go. Square root of 16x. I can already see, I'm not going to break it down all the way, but I can see, I can take the square root of 16. The square root of 16 is 4. And what's going to be left is x. So this just means my a value is 4. So I have a vertical stretch by 4. Now on the second one, I've got a binomial under the radical, and I also see I have a GCF of 9. So let's factor out that 9. 9 times x minus 5. And now the square root of 9 is 3. And what stays underneath is the x minus 5. So here we are. And again, don't forget, this function is equivalent to this function. It is just a different representation. They would produce the exact same graph, the exact same table of values. So now I can see I have a vertical stretch by 3. And my h value is a positive 5. So that means I'm moving my parent graph right 5 units.